Here are the solutions worked out for the review for quiz 1 over sections 1.1 and 1.3. So let's take a look at number 1. Any function or expression of this form is referred to as a difference quotient problem. So we want to evaluate this fraction given a certain function for f of x. So you could do this separately, which is what I showed in class. So the first thing I want to do is just take a look at the first part of the numerator. So off to the side, let's go ahead and evaluate this. So here's our function f of x. So wherever I see an x, I'm going to substitute in this quantity. So first we get 3 times the quantity 2 plus h squared minus 2 times the quantity 2 plus h plus 4. So what we want to do here is multiply this binomial by itself. So now just showing step by step, this is what it's going to turn into. The next part, we can actually go ahead and distribute a negative 2. So we're going to get a minus 4 minus 2h and then plus 4. Now when I go to multiply these three factors together, I'm going to actually multiply these two together first. I'm going to leave the 3 on the outside. Multiplying 2 times 2, that'll give us 4. The outside will give us a 2h. Inside will give us a 2h. And then last will give us an h squared. And if you notice here at the very end, minus 4 plus 4, we can go ahead and cancel those out now. And then we're just left with a minus 2h. Now I want to go ahead and distribute the 3. So we'll get a 12 plus 6h plus 6h plus 3h squared minus 2h. I can combine the 6h's. I'm going to write the 3h squared first. So we'll get a 3h squared. I have 12h minus 2h, which will give me a 10h plus 10h, and then I have a plus 12. So right there is just our first part. Next, I want to go ahead and evaluate f of 2. So this becomes 3 times 2 squared minus 2 times 2 plus 4. 2 squared is 4. 4 times 3 is 12. And then we'll get a minus 4 plus 4, so this is 12. So now when I put this all together, f of 2 plus h minus f of 2 all over h now becomes, this is f of 2 plus h, 3h squared plus 10h plus 12 minus f of 2, so just minus 12. And you know you're going to do this right is if all your constants or all of your terms that don't have an h cancel out. And that's what's going to happen with the 12s. Those cancel out. And now I'm just left with 3h squared plus 10h over h. But I could still simplify further. I can factor out an h from the top. So that will leave me with a 3h plus 10. And when I divide that by h, these h's divide out. So now I'm just left with 3h plus 10, or 10 plus 3h. And there's our final answer. So I gave you guys 2 examples of this. So going back to number 2 here, very similar, slightly different functions. So let's take a look at that. So we have f of 3 plus h minus f of 3 all over h, and our function f of x is 5x. And we have to be careful here with this minus x squared. So again, first I want to figure out what f of 3 plus h is. So that becomes 5 times the quantity 3 plus h minus the quantity 3 plus h squared. So I'm actually going to put this in brackets as I did in class because I need to subtract what's going to be simplified into 3 terms. So I have multiple terms that I need to subtract. So I could distribute the 5. We get 15 plus 5h minus, and then off to the side if it helps, you could write this out. And if we do our first terms, we'll get a 9. Outside will give me a plus 3h. Inside will give me a plus 3h. So that'll give me a plus 6h. And then at the very end, we'll get h squared. But notice I have to subtract all 3 of those terms, which is why I wanted to keep them in brackets. So we're going to get a 15 plus 5h minus 9 minus 6h minus h squared. All the constants should cancel when we go to substitute these in, but for right now, 15 minus 9, that'll give me 6. 5h minus 6h will give me a minus h, and then a minus h squared. So that's just the first part. Now let's go ahead and figure out what f of 3 is. So f of 3 becomes 5 times 3 minus 3 squared, so that gives me 15 minus 9, which is 6. So now when I go to substitute this in, again, f of 3 plus h is this part right here. We get 6 minus h squared minus f of 3 minus 6. Notice those 6's cancel. That's what we like to see over h. So these cancel. I'm left with a negative h minus h squared all over h. I could factor out an h from the numerator. I could take out a negative. I'm not going to. I'm just going to factor out an h. That will leave me with a negative 1 minus h all over h. So again, like the last problem, these h's divide out, and I'm left with a negative 1 minus h, or a negative h minus 1. All right, for the next section, I have absolute value functions and piecewise functions. So for problem 3, we're asked to graph this function f of x. We have to use some transformations here. Then we want to take and look at the graph and write f of x as a piecewise defined function. All right, so again, our absolute value function is f of x is equal to the absolute value of x plus 3 minus 4. The parent graph is just f of x is equal to absolute value of x. So we have a shift of 3 to the left and 4 down. So any parabola or absolute value function is going to have a vertex. So this vertex is going to be negative 3, negative 4. And whenever, if you guys notice with my graphs, I always like to tell you how I'm numbering here. So when I put a 10 at the end, all of these blocks just count as 1. It's always good to do that. So I'm going to go 3 to the left and then down 4. Now, if I had a number out in front other than 1, that would affect the slope, but I don't have a number out in front. It's just understood to be 1. So that's my slope as I count from the vertex, up 1, right 1, up 1, right 1, and so on. But on the other side, to get that V shape, I'm going up 1 but not right 1, or to continue this down 1 and right 1, that would just make the line. I have to go up 1 and then 1 to the left. That's what gives us our V shape. So there is our function. Now what I'd like to do is just split this into two, they're really two rays, but they're two lines, but I'm going to start and stop them at certain points. So I'm going to call this is how you write a piecewise function. It always starts with y, or f of x equals, then you make that big bracket to join the two together. So if I'm focusing right on this part of the v, my y-intercept is at negative 1. And my slope is a positive 1. So if I put that in slope-intercept form, I don't need to put the y equals in here. This is the y equals. I'm separating it. But just to show you, this is going to become y equals positive 1x minus 1. So all I have to do is put this part into the piecewise function on this side. So x minus 1. And this shows up, again, right here, this value is at negative 3. So this graph shows up. I'm going to choose to include the negative 3 here. So when x is greater than or equal to negative 3. This piece that's over here, if I were to still extend it, because I want to find a y-intercept, if I were to extend this part just to give me that idea, my y-intercept here, if you're counting down 1, 2, 3, 4, 5, 6, 7, is at negative 7. My slope, I have to go down 1 and right 1, is at a negative 1. So this line is actually y equals negative x minus 7. But this is the only part I'm putting in here, negative x minus 7. Since I included the negative 3 with the top part, I can't include it with the bottom part. But these are all values to the left of negative 3, so x is less than negative 3. So this whole part right here would be the piecewise function. All right, and here's a graph for number 4. G of x is equal to 2 times the absolute value of x minus 1. So again, we're going off of the parent graph, just g of x is equal to absolute value of x. I'm going to shift down 1 unit, but this too is a vertical stretch, so it's actually going to, in terms of graphing it as slope, it's going to affect the slope. So I'm going to start here. My y-intercept, or my vertex, is going to be, vertex is really, there's nothing inside here, so it's going to be at 0, -1. But how I count, because there's a 2 out in front, I'm counting up to 1 to the right each time as I go off to the right, and then up to 1 to the left to get that V shape. So there is our graph of g of x. All right, as I go to write this as a piecewise function, again, if I look at this part, to just simplify, I'm going to say y equals, again, my y-intercept is a -1 and I have a slope of 2, so it's 2x minus 1. So it looks exactly the same here as if we were to remove the absolute value. So again, how do I start to write a piecewise function? I start with g of x is equal to, and then I make my one bracket here that's going to put the pieces together. So in this case, I believe in my solutions, I decided not to include the 0 here, but it's going to start at 0 and go off to the right. So I'm just going to say 2x minus 1 for all x is greater than 0. So if I'm not including the 0 here, I need to include it in the other statement. So as I go off to the left, my y-intercept is still a -1, but my slope is now a -2. So I get a -2x minus 1. Again, this is the only part I'm putting in here. So -2x minus 1 for all x values less than or equal to 0. So it's your choice if you want to put the line underneath here to include the 0 here. If you do include the 0 here, do not include it here. All right, so the next set of problems deals with determining symmetry with respect to the x or y, or I'm sorry, the y-axis or the origin, and also at the same time, if we're answering that, we're determining if a function is even or odd. So let's go ahead and take a look at number 5. Here we're given h of x is equal to 3x to the 4th minus x squared plus 1. And for some of these, the basic polynomials, you'll be able to tell by looking, but we want to determine algebraically. So you want to go through these steps. First, we show that we're substituting in the opposite of x. So this becomes 3 times the opposite of x to the 4th minus the opposite of x squared plus 1. Now, as I showed you in class, we really have a coefficient of -1. When we raise a -1 to an even power, it turns into a +1. So this first term turns back into 3x to the 4th, minus the second term turns back into x squared, and there's no x with the 1 here, so that just stays. So what we have is matching h of x. So we just want to clarify that and say, well, hey, this is equal to h of x. So h of x is an even function. When h of the opposite of x turns out to equal h of x is an even function. And any even function is symmetric with respect to the y-axis. I'm just going to abbreviate here. Symmetric, and then the WRT with respect to the y-axis. That's what we want to show. And that's the more basic one. For number 6, I gave you a fraction. So f of x is equal to 2x over 7x squared minus 5. So the same thing here, we want to show as we evaluate f of -x. This is equal to 2 times -x over 7 times -x squared minus 5. So the numerator turns into a -2x. Anytime we take a -x and raise it to an even power, it's going to turn back into just an x to that power. So the denominator actually stays the same. Well, we need to determine the numerator did change, so it's not equal to f of x. If we factor out the single negative here, I can move a negative anywhere in front of a fraction, up top, down at the bottom, but if the bottom is a binomial, I'd want to put that in parentheses. So I'm just going to take the negative out of the whole thing and keep the rest of the fraction in parentheses. So this is showing now I have the opposite of what f of x was. So this is the opposite of f of x, and because f of the opposite of x is equal to the opposite of f of x, that makes this an odd function. So f of x is an odd function and is symmetric with respect to the origin. All right, let's take a look at number 7. Here we're looking at g of x is equal to x squared plus 6x minus 4. Now doing a quick check, we have an even exponent here and an odd one here. That's really a 1. So this should come out to be neither, but again, we have to show the step. So we want g of the opposite of x is equal to the opposite of x squared plus 6 times the opposite of x minus 4. So what's going to happen is the first term stays the same. It goes back to x squared. But our second term turns to the opposite, and our last term stays the same. So even if we try to factor out a negative, we would get a negative x squared plus 6x plus 4, and that's not the original. But it's always good to try just in case you're not sure. So we would say this is not equal to g of x. This is not equal to the opposite of g of x. So g of x is neither even nor odd. And is not symmetric with respect to the y-axis or the origin. Some graphs just don't have symmetry with respect to these two parts of the graph. Now question 8 was a little different. It's focusing on the ordered pairs associated with even and odd functions. So if f is even, it's an even function, I should say, and the ordered pair 2, 5 is on f. What this means is if we substitute in the opposite of x, we get the same output. Then negative 2, 5 must be on f. If f is odd, if we substitute in the opposite x value, we get the opposite y value. So negative 2, negative 5 would also be on f. All right, for problem 9, we're focused on just finding the domain of these functions. So for 9A that is, we have f of x is equal to the opposite of the quantity x minus 4 squared plus 7. Well, the nature of this function is that it's squared. It's a quadratic function, so it's going to graph a parabola. And it's going to graph a parabola. If you notice, this very first coefficient is negative, so this is a parabola that opens down. So if we're looking at the domain of any parabola that opens up or down is all real numbers. And we can just write it as negative infinity to infinity. If I were asking for the range, then we would need the vertex. And since it opens down, it would just go as high up as the y value of that vertex, which would be the 7. So if you're interested, even though I didn't ask for this, the range, because the vertex would be 4, 7, the range would just go from negative infinity up to 7, but that 7's included, so that would be the range. But we weren't looking for that. For b, we have g of x is equal to the square root of 2x minus 1. Well, any value under the square root has to be 0 or positive in this case. Our square root is not in a denominator, so it is perfectly fine for the 2x minus 1 to equal 0 or be greater than it. And if we solve this for x, we'll just add 1 to both sides. So 2x is greater than or equal to 1. Divide by 2. Now remember, if you have to divide by a negative, remember that sign is going to flip, that inequality sign that is. But we're not dividing by a negative, so we're good. So x is going to be greater than or equal to 1/2. So our domain, we're including the 1/2. So bracket here, 1/2 to infinity. And you can even graph this on Desmos or on your calculator, and you're going to see that that point starts at the 0, 1/2. All right, for C, we do have a fraction. H of x is equal to 4x squared over 2x squared minus 11x plus 12. So that denominator cannot equal 0. So let's first figure out what's going to cause it to be 0 by setting it equal to 0. And it's a quadratic, so we want to solve by factoring, or you guys can use a quadratic formula if you're used to that and prefer that. There is no GCF, so I'm just going to go and make 2 sets of parentheses, still keep it equal to 0. Factoring a 2x squared is just going to factor into 2x and x, and I need factors of 12. Now notice my last sign is positive, so my signs are going to be the same. And then since this middle sign is negative, they're both going to be a minus, because a negative times a negative will give me a positive. I'm going to just start with 3 and 4. I'm going to put them in here first and then just check. So on the outside, we're going to get a negative 8x, and on the inside, we're going to get a minus 3x. Negative 8x and a negative 3x will give me a negative 11x. If that didn't work, I would just switch them around. So now I'm going to set both of these expressions equal to 0, or these factors equal to 0. So in this case, add 3, divide by 2, so x is going to equal 3/2, and over here x would equal 4. That's what's going to cause the denominator to be 0, so I want to restrict them. I really want to say x cannot equal 3/2 and x cannot equal 4. So in this case, the domain is all real numbers except these. And you guys could even write it out that way if you don't want to use interval notation. You can say the domain is all real numbers except x equals 3/2 and x equals 4. You could say the domain is all real numbers, and then you could just put these symbols in. X cannot equal 3/2, x cannot equal 4. But it looks a little bit nicer, and since WebAssign also had you practice with interval notation, I'm going to do it this way. So we want to go negative infinity. We reach 3/2 first, which is 1.5, so negative infinity to 3/2. Then we join that, or union. Then we go from 3/2 to 4. And then we have to carry on. We have to jump over the 4, so we continue from 4 to infinity. But notice there's parentheses everywhere, not brackets. We cannot include the 3/2 or the 4. And then finally, we have part D. So here, I'm giving you k of x is equal to 6 over the square root of 3x minus 5. So now we have a radical in the denominator, which usually under the radical we're good with 0 or positives, but because that radical's in the denominator, we can't allow 3x minus 5 to equal 0. So in this case, 3x minus 5 must strictly be greater than 0. Add 5, divide by 3. So here we're just not including the 5/3. So our domain, parentheses, 5/3, comma, infinity. So we're good at any value greater than 5/3. Okay, there really is no work involved for problems 10 or 11. So the answers I have written out, it's just by looking at the form that's here. So for 10, if we're given f of x is equal to x cubed, this is still a cubic function here. We have a horizontal shift. Remember, if we see a plus sign there, it really means go in the opposite direction. So this is telling us to go from f of x to g of x. This is only one way to word it. F of x needs to shift 6 units to the left, and then this minus 7 is 7 units down. And those are the only 2 transformations taking place for f of x. For 11, we have a radical x as our parent graph. So like the plus 6 up here, we are shifting 4 units. It's a horizontal shift. It's opposite, so 4 units to the right. And then because we have this negative sign out in front, that's going to flip or take the opposite y value, so it's really a reflection over the x-axis. For problem number 12, I'm giving you a piecewise defined function, and I want you to graph it. So let's take a look at these pieces. We could separate them, but we have to know where we need to draw the graph, where it can show up and where it cannot show up. So the first one is really, we're looking at the graph of y equals 1/2 x plus 3, but it's only showing up for all values less than -2, which is right here. So if I were to graph this, I'm going to start here at 3, but I'm not going to make a mark. So right here, I'll erase that though, but that's where our graph would start. But that's not a value less than -2. So I'm going to erase that, but that's where I'm just going to start. And my slope is 1/2. Now normally I have to go up 1 over 2, but I need to stay to the left of -2. So instead of going up 1 over 2, I need to go down 1, left 2. And if you notice right here, I am over -2. I can't include it. It's just values less than -2. So instead of putting a closed point, I'm going to have an open point. And yes, I'm kind of making it larger than necessary. So from my y-intercept here of 3, I had to go down 1 and over 2. And I want to repeat the process. Down 1 over 2, and I can make a point here. Down 1 over 2 again, just enough until we get enough of points to make a line. So I'm just going to start at the edge of that open endpoint. We want to show that it continues on forever, so we need an arrow at that end. Now in the middle, this is the line y equals 1. That graph's a horizontal line going through 1. So I can include from -2 over to 2. I'm going to put endpoints here, and then I'm just going to have a horizontal line connecting that. So all the y values are just 1. And then my third piece is really y equals -3x plus 10, as long as x is greater than 2. So I need it to show up to the left, or to the right rather, of +2. But I'm still going to go up to the y-axis at 10. I'm not going to make a point, but if you notice I'm hovering up here. My slope is -3 over 1. So I want to go down 3, 1 to the right. So I'll see when I can start making points. Down 1, 2, 3 over 1. I'm still not to the right of 2. I have to go down again. 1, 2, 3 over 1. I'm right over the 2, so this is where I want to start, but I can't include it, so I still want to make another open endpoint. Down 1, 2, 3 over 1. One more time. 1, 2, 3 over 1. And then I can draw my line. And this is our piecewise function f of x. Now the last two problems deal with composition and combinations of functions. So let's take a look at 13. Here we have f of x is equal to 4x squared minus 2x plus 6, and g of x is equal to 2x plus 1. So going through the combinations first, f plus g of x just tells us to add f of x, so 4x squared minus 2x plus 6, add it to g of x and combine our like terms. So there's no other x squared terms other than the 4x squared. Negative 2x plus 2x cancel, and then we can add 6 plus 1, so we get 7. Oh, sorry, it was a minus 1. Go back and fix that. Minus 1, minus 1. So 6 minus 1 would give us the 5. Next we have f minus g of x. We just have to be careful subtracting g of x. So f of x still stays the 4x squared minus 2x plus 6, but minus, since we have two terms here, we want to keep that in parentheses so we distribute the subtraction sign properly. So now we're going to get 4x squared minus 2x plus 6 minus 2x, but then a plus 1. So here we're going to get 4x squared minus 2x and another minus 2x is going to give us a minus 4x. And then here we get 6 plus 1, which will give us a 7. And for the third part, I first wrote it as this notation. This means f of g of x. So we could rewrite it this way. And this means I want to drop g of x into f of x. So wherever I see an x here, I'm replacing it with this quantity 2x minus 1. So then this becomes 4. And this is good practice for like the first two problems when you have to do like f of 2 plus h or f of 3 plus h. This becomes f of the quantity 2x minus 1 squared minus 2 times the quantity 2x minus 1 plus 6. So writing this out is going to be very helpful. We still have to take our time as we multiply the two binomials together. So I'm just rewriting this out so it's easier, hopefully less mistakes. The next part, we can go ahead and distribute the -2. So we'll get a minus 4x and then plus 2. And then we have the plus 6 at the end. So I'm going to go ahead and multiply these two together first. I'm going to still leave the 4 here. Keep parentheses though. 2x times 2x is 4x squared. On the outside, I'm going to get a minus 2x. On the inside, I'm going to get a minus 2x. And then last, we'll get a plus 1. Then we'll still have the minus 4x. And yes, we can go ahead and add these two together to give us a plus 8. Next, I want to distribute the 4. So we'll get 16x squared minus 8x minus 8x, or you can combine those two. And we have a plus 4 minus 4x plus 8. So combining our like terms, we end up with 16x squared. These two right here will give me a minus 16x minus a 4x is a minus 20x. And then 4 plus 8 will give me 12. All right, for 14, we're given g of x is equal to x squared plus 5x minus 4. H of x is 3 times the square root of x minus 1, or 3 radical x minus 1. So first we were asked to evaluate g of h of x. So wherever I see an x here, I'm dropping in this expression very carefully. So we have the quantity of 3 radical x minus 1 squared plus 5 times the quantity 3 radical x minus 1 minus 4. Again, I'm going to write this out side by side to multiply it very carefully. Next, I can go ahead and distribute the 5, so we'll get plus 15 radical x minus 5, and then minus 4. So as I multiply, and I'll show this off to the side, 3 radical x times 3 radical x, this will give us, we can multiply the 3's, we get a 9. Then we get a radical, and anything under a radical we can multiply, so we get an x squared. Well, square root of x squared just gives us an x. So the first, when I multiply the first two terms, we're just going to get a 9x. Outside we'll get a minus 3 radical x. Inside we'll get a minus 3 radical x. Last we'll get a plus 1. Then we get a plus 15 radical x. Then we'll have a minus 9 at the end. So combining like terms here, let's leave the 9x first. Here I have really a negative 6 radical x when I combine these two terms. And then I have a 15 radical x. So 15 minus 6 will just give me a positive 9 radical x. And then we have a 1 minus 9, so we'll get a minus 8. All right, the other way around, if we're looking for h of g of x, this is a little easier. We're going to drop g of x into the spot underneath the radical. So this simply becomes 3 times the square root of x squared plus 5x minus 4. And then we have a minus 1 at the end. Now there's nothing we could do underneath. Doesn't factor, so we'll just leave it like that. And then the last part, I wanted you to calculate g of h of 16. So what this means is we first figure out h of 16. So doing that off to the side, this is just 3 times the square root of 16 minus 1. Square root of 16 is 4, so this becomes 3 times 4 minus 1. That's 12 minus 1, so that's 11. So then we're really looking at g of 11. So remember, g of x was x squared, so we have 11 squared plus 5 times x, so 5 times 11, and then we have a minus 1. I'm sorry, minus 4. 11 squared is 121. 5 times 11 is 55, minus 4. 121 plus 155 is 176. 176 minus 4 is 172.